On behalf of the U.S. Space and Rocket Center, happy International Observe the Moon Night, sponsored by NASA Marshall Space Flight Center's Planetary Missions Program Office here in Huntsville, Alabama. We are very excited to celebrate looking up at the moon with you. The moon is a beautiful world. It is our closest celestial neighbor, and it's so easy to see, and yet, we don't often give it more than a glance or two every now and again. International Observe the Moon Night is a reminder, an opportunity to look up at our moon and explore its many features. There is so much to observe on the moon that trying to find something specific can be a bit tricky, and that's why we're here to help. My name is David Weigel, and I will be your host as we navigate to some of our favorite places to observe on the moon. I suspect that most people have a story, a memory, or at least a vague fondness associated with some time spent looking up at the moon. In college, after a tough day, I would climb up to a good lookout spot on campus to get above most of the lights, and then I'd gaze up at the moon. Sometimes I was alone, sometimes I was with a friend or two. I really wasn't looking for anything specific on the moon's surface, but it sure brought me some peace after a long day, and I really look back on those times fondly. If you have any stories or memories of observing the moon that stand out, please do share with us in the comments below. It turns out that the moon has a story as well, although it is one that we are still trying to understand. As we observe the moon, we can attempt to trace back each and every feature that we see to try to figure out how the moon came to be the way it is.
Speaking of a great lunar observation story, take your pick from any of the Apollo missions that landed on the surface of the moon. Now, when I was a child, I was assigned a project to deliver a poster presentation on the Apollo 11 mission, the first crewed mission to step foot on the lunar surface on July 20, 1969. On this mission, over 50 years ago, humankind made known their technological triumphs and great leaps of discovery. I remember my small steps going outside my childhood home, gazing up at the full moon and wondering what it would be like to be that far away, to see all that ever was for humankind. Was it lonely? Was it cold? Was it scary? I remember fondly of then looking down and seeing my bare toes wiggle in the grass, hearing the screaming frogs and bugs of the country wooded areas where I grew up along the river. I then, with a burst of energy, jumped around the yard, pretending to be Neil Armstrong and Buzz Aldrin. Then stopping abruptly upon hearing my mother scolding me for getting dirty after already taking a bath. I looked back up at the moon and thought, to be an astronaut is to be brave. So I ran as fast as I could and did a cartwheel into a giant mud puddle and splash! And if Neil and Buzz were still on the moon, then I bet you they would have heard my mama screaming at me from 240,000 miles away. The last time humans walked on the moon was in December of 1972 with the Apollo 17 mission. That's about to be 50 years ago. Apollo 17 was the final J-type mission of the Apollo program, after Apollo 15 and 16. The J missions were more science-focused and were the first missions to make use of the Lunar Roving Vehicle, or the LRV, which is lovingly nicknamed the Moon Buggy. The LRV allowed the astronauts ease of mobility and the possibility to travel great distances that weren't achievable in earlier Apollo missions. A valley named Taurus Littrow was chosen as the Apollo 17 landing site and is arguably the most geologically interesting of any of the Apollo landing sites. Taurus Littrow resides in the eastern rim of the Sea of Serenity and is nestled between older silicate-rich lunar highland massifs with the younger volcanic rock in the valley floor. This proximity to different types of lunar rock, combined with increased mobility, meant that Apollo 17 astronauts Eugene Cernan and Harrison Schmitt had excellent opportunity to conduct science, and select lunar samples. Cernan and Schmidt drove over 22 miles in the Huntsville-designed and built LRV. Now, one of the more exciting stops of their drive was to explore a boulder field in the Taurus-Littrow Valley, in which boulders had rolled down the North Massif. Tracks of the boulders are clearly visible in imagery taken by the Lunar Reconnaissance Orbiter, or LRO. Rock samples taken from the North and South Massif, along with the sculpted hills returned to Earth by the Apollo 17 astronaut crew, provided insight that the Sea of Serenity was likely 3.89 billion years old. More recent observations from LRO have called this into question, proposing that the sample material was actually ejecta, or debris from the cataclysmic impact that formed Mare Imbrium to the west. As we await further study, I think this further highlights the role that observation of the Moon has in helping to tell its story.
The Moon likely formed when a Mars-sized impactor smashed into the Earth some 4.5 billion years ago. Some of the molten remains from this violent cataclysm formed into a sphere due to gravity, and eventually the magma began to cool enough such that a solid crust could form around a still molten interior. Around 4.3 billion years ago, an enormous impactor crashed into the south pole of the Moon, carving out the South Pole Aitken Basin. This was the beginning of a tumultuous period in our early solar system's history that we call the Late Heavy Bombardment, which occurred about 4.1 to 3.8 billion years ago. Impact after impact occurred on the surface of our young Moon. Since the lunar interior was still molten, the collisions cracked the relatively thin lunar crust, triggering volcanism and allowing lava to seep into the sort of low-lying areas formed from these very violent events. As the lava flowed on the surface, this lava rock solidified to form the largest impact basins on the Moon that we now refer to as the Maria. The lava rock is basalt, just like we see here on the Earth, and since it is iron-rich, it is darker in color and less reflective than the silicate-rich lunar surroundings. Volcanism on the Moon ceased around 1 billion years ago, but impacts persisted. After the Late Heavy Bombardment, collisions were smaller and less frequent, but continued to occur for billions of years. Craters, the scars of these impacts, can be seen scattered over every inch of the Moon. The youngest and most prominent craters that we see today all formed within the last 1 billion years or so. These craters have rays extending away from them that are debris from their impacts, strewn all over the surrounding landscape. We'll explore a few of these craters a little later.
As a kid, I was fascinated with our Moon. Whenever I couldn't sleep, I would look out my bedroom window, and using the lighter and darker regions on the Moon, I tried to see different shapes on its surface, kind of like one might do with clouds in the sky. As I grew older, I began using a telescope in my backyard to examine these features more closely. I wanted to be able to see those darker patches on the Moon because I wanted to know what they were made of. But it wasn't until I was in college that I learned what those regions actually are. Now, what I had been seeing all those years ago are some of our Moon's most prominent surface features. The lighter regions on our Moon are called lunar highlands. They are more reflective and contain most of the impact craters on our Moon. But those darker patches are called Maria, which is a Latin term that translates to seas or oceans, because back when 17th century astronomers were naming these features, they thought they were looking at oceans on our Moon when they saw those darker regions. Now, over time, we realized that Maria are not actually oceans of water, but rather smoother areas of ancient lava rock. Because if you'll remember earlier, we learned that Maria were formed from impacts and volcanic activity during the late heavy bombardment period of our solar system. There are roughly 20 of these regions, and though they contain no liquid water, Maria are still named as if they were seas. So in each name, we will see the word mare, which is the singular version of Maria. For example, the easternmost mare on our moon is named Mare Fecunditatis, which means the Sea of Fertility. This mare is home to one of my favorite craters called Messier, which you'll get to learn a little bit about later. But this is a good starting point to begin our journey through some of the largest maria on our moon. If we take a look at the large spot to the left of Mare Fecunditatis, you have now found Mare Tranquillitatis, the Sea of Tranquility, where humans first landed on the moon during the Apollo 11 mission back in 1969. Now, since then, humans have been to the moon an additional 5 times, and that number will soon increase with NASA's Artemis program. In fact, 50 years ago, this December, Apollo 17 astronauts landed in the neighboring mare called the Sea of Serenity, or Mare Serenitatis, where astronauts hoped to find samples of nearby mountain regions. But no mare has more mountains than Mare Imbrium, the Sea of Rains, a region which is surrounded by 3 rings of mountains. And to the north of Mare Imbrium, you might notice a long, thin shadow stretching across the near side of the moon. This is my personal favorite, Mare Frigoris, the Sea of Cold. This snake-looking mare is roughly 100 miles long, but it is still not the largest mare because on the very far west side of the moon, we have Oceanus Procellarum, the Ocean of Storms. And it is the only maria which is named after an ocean rather than a sea because it is the largest of maria, so big that it covers over 10% of our moon's surface. And keep in mind that all lunar maria combined only cover about 16% of the lunar surface, almost all of which we see on the near side of the moon. And we've now covered the 6 large maria on the moon, which were named after seas and oceans, but there are also many other maria as well as smaller regions named after marshes, lakes, and bays. And if we look at all of these regions together, those darker regions can appear to form different shapes on the moon as they're silhouetted against the lunar highlands. Now, for centuries, people have seen things like a man in the moon, a rabbit, or perhaps even the shape of a snake. So while you are looking at the moon tonight, take a look at those maria and ask yourself, what shapes do you see?
Speaking of shapes, while the maria make up large shapes on the surface, there are very many more medium to small features on the lunar surface that are the result of smaller impactors that we call craters. Craters are the excavated remains of chance collisions with chunks of asteroids or other space debris. Craters can come in all shapes and sizes. Some are simple and rather bowl-shaped. Some are more complex and have mountain peaks at their centers. The maria are easily visible with the naked eye, and a few craters are as well, but for the most part, it helps to observe craters with binoculars or a small telescope in order to find them and explore some of their structure. The imagery of the craters that we will highlight in this video is thanks to the Lunar Reconnaissance Orbiter, or LRO. This spacecraft orbits the moon to map it at stunning resolution of up to 20 inches per pixel. For International Observe the Moon Night last year, we explored some of the most prominent craters on the moon's surface, and we'll link to that in the description below if you'd like to learn more. This year, we've selected our favorite, easy to find, yet perhaps underrated craters. First up, I want to talk about Stevinus. Stevinus is a very visible crater, mostly due to its bright crater ray system. Its prominent ray system gives us a good indication of its age. Stevinus was likely formed in the last 1 billion years or so. That's relatively young for a crater, even though it sounds quite old. Stevinus is over 45 miles across and almost 2 miles deep, and is a perfect example of a complex crater. Complex craters are large with flat floors, They have a central peak system and terraced walls. Stevinus also has some very interesting dome shapes on its floor. We don't really know what they are or how they formed. It could possibly be from lava that has squeezed up through cracks and holes as the impact melt cooled and solidified, or it could be from a local source of magma. There's a variety of these structures on the floor in Stevinus. Some are dome-shaped, others are pancake-shaped, some even have X's. The cracking that we see may have been formed when impact melt beneath a solid yet thin crust pushed up and fractured the crust.
The moon has a story to tell, and by observing craters, we can learn more about the moon's history. Lunar impact craters can act as excavators and reveal layers of terrain hidden below the surface. Craters formed on the Maria, like Picard crater, the largest crater formed in Mare Crisium, are a great example of this. When we look at both the walls and the floor of Picard, we can see a mixture of brighter and darker materials. The brighter material is highland rock that was once covered by Mare Crisium, and then finally exposed by the formation of the crater. The dark material is basaltic rock, or rock that was formed by lava. The visible dark patches are actually dried pools of impact melt. Impact melt forms when an asteroid hits the moon, and the pressure and temperature are so intense that the surrounding rock can actually instantaneously melt. We also can see some cracks in these dark pools. As that impact melt cools and solidifies quickly, it will fracture. Picard crater is full of these dried, cracked pools. Now I know what you might be thinking. This crater has a pretty epic name. However, Picard crater was actually named after the French astronomer Jean Picard, not the Enterprise captain Jean-Luc Picard. Sorry to disappoint you. Now, I love to look at the moon every night. I really enjoy watching it change from day to day, or rather night to night, and to see what features are visible depending on the phase of the moon. Sometimes I think if I can squint my eyes hard enough, I might be able to pick out some individual craters or some amazing features on the surface. Well, of course, I can observe the moon with just my eyes. I really enjoy looking at some of the stunning imagery from the LRO, even more. With the LRO, we are able to resolve incredibly small details on the moon. A crater with plenty of amazing details to check out is Posidonius. Posidonius crater is a large crater next to Mare Serenitatis. This crater is incredibly old. Scientists estimate it was formed around 3.6 to maybe even 3.8 billion years ago. And in its long life, Posidonius crater has experienced extensive modifications. The crater's interesting characteristics are partially due to its location. Posidonius was formed in between the Mare and the Highlands. Mare Serenitatis shaped many of the features in Posidonius. Posidonius is what we call a floor fractured crater. After its formation, magma seeped in and literally uplifted the crater floor. Some lava also partially covered that central peak system, as well as the rest of the crater floor. This magma intrusion also fractured the crater floor and formed grabens. Grabens are these long depressed blocks of the crater floor, and some of the largest ones here in Posidonius are over 100 feet deep, a half-mile wide. Magmatic and volcanic activity from Mare Serenitatis appear to have destroyed much of the crater rim. This lava flow also possibly created a moat that separates what's left of the crater wall and the crater floor. However, the most intriguing feature, in my opinion, is the sinuous rill. Rills are some of my favorite things to look for on the moon. They were formed by lava flow, either by a river of lava carved its way through the surface, or by a subsurface lava flow that then collapsed into the channel we see today. This rill in particular is a half-mile across, about 300 feet deep, and well over 100 miles long. And to top off this interesting crater, we see a number of simple craters that were probably formed after Posidonius's stressful time. A simple crater is a crater that's only a few miles across and tends to be bowl-shaped. The large one near the center is named Posidonius A. Posidonius B is the simple crater on the rim, and Posidonius C is the smaller crater below Posidonius A. Now, out of all of these fascinating features of Posidonius crater, which one is your favorite? Let us know in the comments.
When we think about craters on the surface of a world, often we imagine this impact region that has a fairly circular shape to it, and we see examples of this scattered across the surface of the moon. But sometimes you come across craters that have irregular shapes, craters that aren't perfect circles, and are more maybe elongated than usual. This is usually caused by the object that struck the surface and the angle from which that object approached the surface as well. Now, what we see here are two oddly shaped craters, Messier crater on the right and Messier A on the left, named after the famous French astronomer Charles Messier, who is most famous for the Messier Catalogue, which is the series of deep space objects, things like galaxies, nebulae, things of the sort. Now, Messier crater has a very elongated shape to it, which almost looks like a football, and Messier A, from what I've been told, kind of looks like Baby Yoda. We also see these beautiful white streaks that stream off to the left, which are referred to as crater rays. Now, these are rays of ejecta caused by an impact. Because of their strange shapes, because of this crater ray system, we're able to unravel the events that cause this impact, cause these craters and these rays, sort of rewind time. It's thought that an asteroid came in from the east, struck the surface at an angle of 3 to 5 degrees, which created Messier crater. But then it bounced, as if you took a rock and skipped across a pond, which created Messier A. Other craters that we can observe surrounding this ray system are also a result of this rocky debris escaping from that second collision, causing Messier C, D, and so on. Now, looking at these two, I mentioned one looks like a football, one looks like a Baby Yoda. It's hard to gauge their size though, so let me give you some numbers. From end to end, 8 miles. As far as across, it's about 4 to 5 miles. And if we take a deep dive inside of this crater, you notice that things start to get a little messy. These are very steep crater walls that have a depth of 4,265 feet deep. Now, the Saturn V rocket that took humankind to the moon for the very first time stands at about 363 feet tall, and it would take over 11 to reach the top of this crater. That's how big this crater is. You have no problem finding these two through binoculars and/or a telescope. Another example of a crater with a very unique shape to it is one that can be spotted or located in between the Sea of Tranquility and the Sea of Crisis. Now, most craters are named after famous astronomers, philosophers, mathematicians, and Proclus is not the exception, as it is named after one of the last Greek philosophers, Proclus of Athens, whom was a successor of Plato. Now, this is a very prominent crater and fairly easy to spot due to its high albedo, which can be attributed to yet another crater ray system. These rays extend out a distance of over 370 miles. But what stands out with this system in particular is the zones of avoidance to the southwest. We see rays extending out to the north, to the east, and partially to the south. But then, there's this region that lacked them completely. And this is thought to be another example of an impactor coming in at a very, very low angle, just like Messier crater. This non-continuous distribution of rays tells us that because the rays appear to be directed toward the northern hemisphere, the projectile that made this crater, that created Proclus, came in from the east, or potentially southeast direction, and was formed by an oblique impact at a low angle. Now, the crater itself is also unique in the fact that it has a very distinct pentagonal shape to it. These shapes of these craters are very dependent on the shape of the impactor, the angle in which it strikes, and also whether the projectile struck as a single solid object or broke apart during impact, causing secondary craters as a result. Proclus has a diameter of 18 miles and is about 3.5 miles deep and is thought to be a relatively young impact region, no older than 1.1 billion years old. Now, there are various ways to determine an age of an area, one of which is counting craters. So the more craters you see in a region, the older it is. Another way you can determine age, though, is by the brightness of crater rays. If the rays are very bright, it's probably a relatively young impact region. The reason that they can stay bright for so long is because the moon does not have an atmosphere. So there's no wind, there's no water erosion. The only kind of weather the surface experiences is through solar winds from our star. Now, the fainter a ray system, the older the impact area. This is an easy crater to spot and observe, and I invite you guys to go outside and try and find Proclus on your own. And feel free to comment in the comment section if you could see the bright crater rays all the way from the Earth.
It is probably clear by now that we are very fond of craters, and upon looking at the moon, it's perhaps further clear that there are plenty to choose from. But how many is many? Turns out, there are about 25,000 craters larger than 6 miles in diameter, but those are just the really big ones. If we expand our observations to include craters larger than 1 mile across, our total increases to about 650,000. Surveying craters like this helps us to better understand the moon's story. We can compare the near side of the moon, that is, the side that always faces the Earth, with the far side, the side that doesn't ever face the Earth, the side that we never can see from the Earth. And when we compare these two, our observations quickly show that the lunar far side is very heavily cratered, and while the near side is home to a lot of craters, it's also home to most of the maria. Even though both are old, the highlands are older, those brighter areas are older, and have had more opportunity for impacts.
Now, we've talked a lot today about the story of the moon leading up to the present, but the story of our moon is far from over. The best way to observe the moon is, of course, in person. Now, while humans have not stepped foot on the moon in almost 50 years, NASA will change that with the Artemis program. The Space Launch System, or the SLS, the rocket that will eventually see humans back to the moon, will launch soon. I will be at the US Space and Rocket Center in Huntsville, Alabama, at their Artemis launch party, watching the launch of this special program alongside so many who have worked to make this moment a reality. Now, Artemis 1, launching soon, is an uncrewed test flight for both the SLS and the Orion spacecraft, and is equipped with robots and test dummies. Artemis 2 will be crewed, performing testing in low Earth orbit before boosting into a free return trajectory around the moon and returning to the Earth. Artemis 3 will be a crewed lunar landing, seeing humans walking on the moon once again, and some historic firsts. The first woman and the first person of color walking on the moon. The tentative destination? The mysterious lunar southern pole. Why mysterious? Well, let me put it this way. When I first began learning astronomy, the moon was one of my favorite subjects to observe. I would drive to the local state park on full moon evenings and look up with a pair of binoculars, observing various features like the mare and the highlands. After all, it is the second brightest object in our sky and is great for naked eye observation. However, because of tidal locking, areas like the dark side of the moon and the poles are beyond our eyes' reach. Now, while I can't see it for myself, I can observe the dark side of the moon with data from the Lunar Reconnaissance Orbiter and other missions. The South Pole, though, well, because of the way the moon orbits around the Earth, there are craters here whose floors are almost permanently in shadow. So, we can't see the South Pole because of how we are looking at the moon from the Earth. Things like orbiters can't see the bottom of these craters because of the lack of light. The moon is our closest celestial neighbor, and here, a blank spot in our view. The mystery of that is something that intrigues me and excites me. Now, data from the Lunar Reconnaissance Orbiter suggests that there is a lot of water ice on the floors of these craters. And Artemis 3 is looking to sample this water ice to see what more it can tell us about the moon's long history. Since these craters are almost permanently in shadow, the water here, it would have never had the chance to evaporate, meaning that it has likely been around since the early times of the moon's existence. The moon has a lot of mysteries in its story, many places that still need to be observed, and I look forward to seeing them explored. Furthermore, the goal of the Artemis program is establishing a long-term presence on the moon, with eventual yearly flights to the moon and humans living lives there. While the moon's story is long and illustrious, our story with the moon is really just beginning. We are ready, and we are going back.
We are ready, and we are going back. Exciting, isn't it? Whether you're an astronaut who gets selected to fly on an Artemis mission or not, we all have the opportunity to be a part of uncovering the moon's story as we observe together. So take this as an invitation to gaze up at the moon tonight, or at least very soon. And while we're looking up, we can create new stories and memories of our own. I would like to thank NASA Marshall Space Flight Center's Planetary Missions Program Office for sponsoring this video. My name is David Weigel, and on behalf of the Intuitive Planetarium and the U.S. Space and Rocket Center, happy International Observe the Moon Night. Thank you for watching, and be sure to get excited as you look up at the moon.